Okay, so let's say you roll a die 3 times. What are the different ways you can roll 6? So a die has 6 numbers on it, 1 through 6. So you can roll 6 on your first roll. So it could be a 6, non-6, non-6. Or you can roll 6 on your second roll, non-6, 6, non-6. Or you can roll 6 on your last roll. So there's 3 different ways you can roll 6 exactly once out of 3 times. All right, 3 choose 1. And if we extrapolate that idea into doing it, maybe getting no 6s or 2 6s or 3 6s, all right? So if I want to know the probability of rolling a die 3 times and getting a 6 every time, it's going to be 1/6 cubed. Because there's a 1/6 chance on the first time, 1/6 chance on the second time, 1/6 chance on the third time. And I multiply them because these are independent of each other. Now rolling 2 6s, well, I could get a 6 on my first 2 rolls, and then a non-6 on my last roll. I could get my non-6 on the middle roll, or my non-6 on the first roll. So if we add all those up, there's 3 ways to do it. So it's going to be 3 times 1/6 squared times 5/6. All right, there's also 3 ways to get 1/6. It could be 6, 2 non-6s, non-6, 6, non-6, or 2 non-6 and a 6. So 3 times, and the 3 is coming from 3 choose 1. Now, no 6s, there's only one way to do that. So that would be like 3 choose 3 non-6s. So it'd be 5/6 to the 6th power. So this pattern should kind of recognize something, or remind you of something, and that's the binomial theorem. That's why this is called binomial probability. Now, if you added up all these probabilities, that would be 1 for 100%, because there's a 100% chance if you roll a die 3 times, you get all 6s, 1 6, 2 6, or 3 6s. And notice how it looks like the binomial theorem. So I would write this down. This is how we do binomial probability. So you use it when you're doing a set number of trials and you want to know the probability of getting a certain number of successes in those trials. So success doesn't need to be like a success in terms of like how you normally think of success. It just means like either like you get a 6 could be a success, or you don't get a 6 could be a success, or like tails could be a success, or rolling an even number on a die could be a success. Okay, so it's not like, oh, you're successful. It's not like that. So it's a number of trials, choose a number of successes, and then the probability that that success is going to happen, raised to the number of times you want that success, and then times the probability of the success doesn't happen, so we call it a failure, and then that number, just like the binomial theorem, should add to r to give us n. Alright, so I would write this down, and I'll show you how it works. So, you flip a coin 10 times. What's the probability of getting exactly 4 heads? Alright, so we don't want to do this. We don't want to say it's 1/2 to the 4th, because the probability of getting heads would be 1/2, and then times 1/2 to the 6th, because the probability of getting tails would also be 1/2. Because that would specifically be like getting heads, 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 and then 6 tails. Alright, but we know that there's a lot of different ways to do that. Well, how many ways? Well, out of the 10 flips, choose 4 of them to be heads. Okay? And then we're just going to type that in the calculator. So if I just write this out again, kind of explaining where this comes from. So 10 flips of the coin, choose 4 of them to be heads, times the probability of heads, which we'll call success. That's going to happen 4 times. Times the probability of tails, which we'll call failure. That's going to happen 6 times. Notice how these two add up to 1. 1/2 plus 1/2 is 1, because there's a 100% chance you get a head when you flip a coin, or don't get heads. And type that in the calculator, and you get your answer. Okay, and we see that the probability of that happening is around 1/5, 105 over 512. Alright, let's do one more quick example with that, and we'll call it a day. Okay, let's shake it up a little bit with a boardwalk question. So let's say you're on the boardwalk and you're playing this spinner, trying to win maybe some candy, and you like your mom, so you play mom. Okay, so that's 1 spot out of 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, 6, 7, 8, so 40. So the probability of a success here, like winning if you played mom, would be 1 out of 40. So the probability of failure would be 39 out of 40. Now, if you played once, then your probability of winning is just 1 out of 40. But let's say you played 5 times, and you want to know what's the probability you win exactly twice if you played 5 times. So out of the 5 games, choose 2 of them to be winners. So 2 is a winner, that's a success. The probability of a success winning is 1 out of 40, so we put the 2 up there. And then if you win twice, you lose 3 times. So we'll put the 3 right up there. Type that in, and that would be your probability of winning twice. Okay, so we could see by typing in the calculator that chances are pretty slim. All right, just winning once is pretty slim, 1 out of 40. So winning twice is 0.5%. And that's it.